Good morning, children. Welcome to class 12 online chemistry class. We had started the unit 11 alcohols, phenols and ether. Last class I have completed phenols. So today I'll start alcohol. We will discuss today the functional group alcohol, its orbital structures, classification of alcohol, IUPAC nomenclature, and the various ways of preparation of alcohol. In the next class, we will complete the properties of alcohol, both physical and chemical properties, along with the mechanism. In this context, I'd like to tell that there are three mechanisms. You could get it in page number 321, page number 331 and page number 337 of NCERT part 2. That is, one mechanism is related to the conversion of alkene to alcohol. One is to, that is page number 321. Page number 331 is from alcohol to alkene. It is through dehydration. And page number 337 is alcohol to ether. That is also another kind of dehydration, especially intermolecular dehydration reaction. So these are the three mechanisms. Out of this, one is almost a mandatory question of 3 marks in board. The question comes as there are statements and the steps. In fact, there are 3 statements corresponds to 3 steps. Each step carries out half marks and each statement 2 half marks. Thereby, it is half into 6, 3 for statement and 3 for the electron shifting equation representation. Thereby, it is as a whole a 3 marks question. If you will complete this 3 mechanism in toto, whatever is explained in NCERT or whatever, howsoever I am writing. So, if you are well practiced with this 3, then it's evident that you will definitely get 3 marks. You are able to score this 3 marks undoubtedly. Now, let's start this. The first one, alcohols. Functional group is OH. In fact, these alcohols and ethers both are the derivatives of water. If one of the hydrogen is replaced by alkyl group, this is alcohol. And if both the hydrogen are replaced by alkyl groups, this is known as ether. In this ether, if R is equal to R dash, it is a symmetric ether. And if R is not equal to R dash, it is unsymmetric ether. In alcohol, the functional group is OH. Here the bond polarity plays an important role, and in fact it is the oxygen which is once bonded to carbon of the alkyl group, as well as this is bonded to hydrogen. So this relative bond strengths actually determine how this alcohol would behave. One more thing, that this alcohols and ethers with same molecular formula, these are the functional isomers. With a general formula CnH2n plus 2O. So in fact, if we'll take an example of N is equal to 2, it will be C2H, 2 into 2 plus 2 means it is 6O. Corresponds to this molecular formula C2H6O, we could have one alcohol as OH, the other two carbon with tetravalencies, that means this will be ethanol. Another could be ether with divalent oxygen as the functional group to satisfy the tetravalency. This is methoxymethane, or dimethyl ether, the common name, and its common name is ethyl alcohol. Now we'll come to the classification of alcohol. The first basis of classification of alcohol is based on number of OH groups or hydroxyl groups per molecule. If suppose only one OH group is present, it is known as monohydric alcohol. If two are present, it is dihydric. If three are present, it is trihydric, and so on, polyhydric alcohols. So this will be an example of monohydric alcohol. This is an example of dihydric alcohol. Similarly, we could have trihydric alcohols and so on. The most important thing is one carbon cannot have more than one OH, then it would be unstable. The second basis is based on the hybridization. Based on hybridization of carbon bearing OH group. Especially this is a category, what I am doing, that is restricted to monohydric alcohol. So let's see how this classification is made. We could have sp3 hybridized carbon bearing OH, or we could have sp2 hybridized carbon bearing OH. This sp3 hybridized carbon could be of three types. One is alkyl alcohol, one is allyl alcohol, and one is benzylic alcohol. In sp2 hybridized carbon, we could have vinylic alcohol, or we could have phenol. Let's see how we can actually make this. In fact, if this is just an alkyl group and this carbon bearing OH is sp3 hybridized, this is an example of alkyl alcohol. This is also no doubt sp3 hybridized carbon, but this is adjacent to another sp2 hybridized carbon. So in this case, this is sp3, but this sp3 is adjacent to another sp2 hybridized carbon. This will be allylic alcohol. And if this is attached like this, further, this is also sp3 hybridized carbon attached to another sp2 hybridized carbon or adjacent to sp2 hybridized carbon. This is benzylic alcohol. The basic difference is this sp2 hybridized carbon adjacent one or beta carbon is actually a part of aromatic group or benzene ring, then it is benzylic alcohol. Non-benzenoid or a straight chain normal unsaturated one, then this is allylic alcohol. Whether it is alkyl or allylic or benzylic, it could further be classified to primary, secondary or tertiary alcohol. Primary or 1 degree alcohol, secondary or 2 degree alcohol, and tertiary or 3 degree alcohol. In primary alcohol, howsoever, with at least 2 hydrogen would be there. In secondary, we know only 1 hydrogen would be there, and in tertiary carbon there will be no hydrogen. So this is how a benzylic alcohol or allyl alcohol or alkyl alcohol could be primary, secondary or tertiary. Now coming to this vinylic and alcohol and phenol. It's directly if OH is attached to benzene ring or aromatic ring, this is the example of phenol. But if this is sp2 hybridized carbon but it is not in an aromatic ring, this is the example of vinylic alcohol. So this is how we are classifying the alcohols. Preparation of alcohol. The first method is alkene. From alkene, it is actually our acid catalyzed hydration of alkene. This addition occurs according to Markovnikov's rule. So in this, actually, if we suppose take ethene and we will add water in presence of dilute H2SO4, H goes to this carbon and OH to this carbon, and thereby we will get ethanol. It's obvious that this addition would be according to Markovnikov's rule, that is, hydrogen would be added to the carbon having already larger number of hydrogen. So if we'll start with propene, we will get 2-propanol. The mechanism is shown as in the first step, the water takes up H plus from sulfuric acid and forms hydronium ion H3O plus. The first step of this mechanism, the statement is protonation of alkene to form carbocation through electrophilic attack of hydronium ion. That means it is our alkene moiety where H3O plus is being attacking. So what happens that this positive charge is taken up by the pi electron cloud to form and water will be coming out. In fact, when this shifts over here, this is moving out as the form of H2O, and this H plus is actually taken up by this. So it forms a carbocation. This carbocation is obvious that it is stable as tertiary followed by secondary, then primary. Accordingly, the carbocation will make its arrangement. In the second step, we have the nucleophilic attack. On carbocation, and from where we are getting the nucleophile, it is the unshared pair of electrons present in water. So this unshared pair actually attacks over here, and we are able to get this is called a protonated alcohol, or also known as oxonium ion. In the next step, we have the release of H plus from oxonium ion, or also known as deprotonation. One of the H is released because of this oxygen being electronegative gets a positive charge which makes it little unstable, and thereby we will be able to synthesize alcohol. This is how alcohol is formed through acid catalyzed hydration of alkene. The next one is also from alkene, but this is hydroboration oxidation of alkene. In hydroboration oxidation of alkene, the addition of OH group is just contrary to Markovnikov's addition, and we will take alkene as 3 units for each unit of hydroboration. BH3 is for hydroboration, and for oxidation we used to take hydrogen peroxide in presence of H3O plus. This is as a whole 1 unit. So hydroboration means borane is BH3. These 3 hydrogen are replaceable and consequently attacks over the pi electron cloud. Let's see how the reaction is taking place. This is the first unit of unsymmetric, or first molecule of unsymmetric alkene. BH3, I am writing it as HBH2. So this addition would take place as per anti-Markovnikov's addition. So hydrogen will go to the carbon having lesser number of hydrogen, means hydrogen will go to this carbon and BH2 to this carbon. So what we are getting, this will be CH3, CH2, this hydrogen is being added, this is single bond CH2, BH2. This will take up one more, that is the second unit, CH double bond CH2. This is the second unit. Now in the second unit, again, one of this hydrogen would be added to this carbon and rest whole part would be added to this carbon. So what are we getting? This will be CH3, CH2, CH2 as this. Next, B, it is no more H2, one H will be there and another H will be joined over here. But this boron would be joined to this carbon. So it is CH2. Now this will become again CH2. This is CH2, CH2 and CH3. So actually we are getting CH3, CH2, CH2 whole 2 BH. This will be further added to another unit CH3, CH double bond CH2. Now this hydrogen would be moving to the third unit, this carbon. And thereby what we are getting, this other unit to be joined over here, CH3, CH2, CH2 to be joined to 3 parts of boron. This part is still hydroboration. After that the oxidation would take place. We use H2O2 in presence of H3O+. How this oxidation part would take place? The bond would shift from here. This part will get OH, this part will get OH of hydrogen peroxide. This is another OH, this is also another OH, this is also another OH and this is another OH. So thereby what are we getting actually? It is 3 units of CH3, CH2, CH2OH plus BOH whole 3. This is how hydroboration oxidation takes place. And this is of course in contrary to Markovnikov's addition. The next preparation is from carbonyl compounds. Here, if we start with aldehyde with hydrogen palladium or with sodium and alcohol, we will get primary alcohol. Let us take an example of CH3, CHO. When it is treated with nascent hydrogen or simple hydrogen in presence of palladium, the carbon oxygen double bond is opened and we will get OH, that is primary alcohol or ethanol. So ethanol is giving us ethanol. Similarly, if you start with a ketone, it requires a relatively stronger reducing agent, for example NaBH4, then it succeeds to give secondary alcohol. We have RC double bond O, R dash, in presence of this nascent hydrogen. By sodium borohydride, we will be able to synthesize secondary alcohol. That is, propanone will give isopropyl alcohol. The next one is from Grignard's reagent. So Grignard's reagent is alkyl magnesium halide. When this Grignard's reagent is treated with formaldehyde, we will get primary alcohol. With any other aldehyde, that is aldehyde other than formaldehyde, we will get secondary alcohol. and with any of the ketone we will get tertiary alcohol. Let's see how the reaction takes place. When we will start with methyl magnesium bromide and say suppose formaldehyde. It is a nucleophilic addition reaction of aldehyde or ketone. I'm showing how the reaction is taking place. This is simply plus minus, and the methyl magnesium bromide is, of course, this part is plus and this part is minus. This whole part is plus and this whole part is minus. So it's obvious that the nucleophile will go to this carbonyl carbon and MgBr will go to this oxygen. So what we will have, CH3 to be added to this carbon and OMgBr over here. The subsequent hydrolysis of the product will change this to alcohol. So this is CH3, CH2, OH. This part will be OH, CH3, CH2, OH plus Mg, OH, Br. This is how our primary alcohol is synthesized. When we will treat it with any other aldehyde, keeping the same as methyl magnesium bromide, plus suppose I am taking this as acetaldehyde. So the same reaction would take place as plus minus, the nucleophilic addition, and the carbonyl carbon also would be plus. So it would be CH3, CH, this part will have OMgBr and this will be CH3. Subsequent hydrolysis will produce CH3, CH, another CH3, OH, that is isopropyl alcohol or 2-propanol with MgOH, Br. That's how secondary alcohol is being synthesized. Coming to tertiary alcohol, if we'll take any ketone, the similar reaction would try out. You can also do it by your own. So this makes as CH3 and this is as OMgBr. This on hydrolysis would give us this is how the tertiary butyl alcohol is made. Coming to the last preparation of alcohol, that is from carboxylic acid. We generally use lithium aluminium hydride as the reducing agent to give it to primary alcohol. But lithium aluminium hydride is quite expensive, and if we will just see this in NCERT, it is also written over there clearly in page number 330 that lithium aluminium hydride is an expensive reagent, so therefore used for preparing special chemicals only. Commercially, acids are reduced to alcohols by converting them into esters. First, these are converted to esters through esterification reaction. After that, esters are treated with hydrogen in presence of palladium or catalyst, when we will get RCH2OH, means this part will be changed to primary alcohol, and we will get back R-OH, what we have used for esterification reaction. So that's how the reaction is actually carried out.